Hello everyone, my name is Amir and today I'm gonna talk about our paper GlotScript, a resource and tool for low resource writing system identification. This is a joint work with my collaborators from LMU Munich and Sorbonne University. A script or writing system identification. Given a Unicode character, what would be the simplest way to return its script? This question was asked more than 12 years ago and still it's not very easy to answer. One might say we can use language identification models as a script identification tool. And this is not a good answer because language identification models first don't know every script and also prone to high error rates. So here, for example, I used a Silati language text which is written in Silo script and uh, uh, do the prediction for the FAST6 language identification, and as you can see it is classified as English Latin with a non-zero probability. And this is because most of the language identification models such as FAST6 and Silati use hashing instead of the saving the actual engram. They do this because there are lots of engrams to save and they cannot save all of them, so they just save the hash of those engrams, and also they try to bond it into a memory so it doesn't use many memory, and so the hash collision may happen even for this script that even didn't seen during the training is predicted as another language. So because of these reasons, we decided to design a script identification tool. Our tool name is GlotScript tool. It is written in Python and can identify all of the 161 Unicode scripts. And also we designed it in a way that can be helpful to the NLP community, meaning that it returns the labels based on the ISO codes and also can return the distribution over all of the characters. So here, for example, as the second example in the figure, you can see we use a code switched data into different scripts of Latin and Arabic, and it returns as the main script. The script of the text is Latin with 75% of the characters, and also the other character is Arabic with 25% of the characters. Till now, with our script identification tool, we can find out what is the script of a given text. But what is the relation of text script with language? So we were wondered what is the attested writing systems for each language. For example, if somebody gives me a sentence written in the Honey scripts and claim that it is Turkish, should I accept it as a common sense or not? And so with having this question in our mind, we designed a GlotScript resource. It's a metadata for each language that provides two different categories of the writing systems that's supported by that language. We called one of them core, which is the official and most used scripts in that language, and the other one auxiliary, which might be the scripts that have been used in the past, or it's adapted by religious book, or maybe the social media community uses it. So here, for example, for Turkish, we have the actual main script as Latin, but we know that Turkish used to be written in also Arabic, so we put the Arabic as the auxiliary. And we tried to support all of the possible languages, meaning more than 7,000 languages. And how we compiled this resource, it was just the agreement over multiple sources that we could access and have this metadata. Um, One of them also published in the LREC 2022, and uh, the other one is Wikipedia, SIL, and other communities that we can get such metadata. Now, the use cases. The first use case we want to talk about is the corpus cleaning and quality assessment with the help of GlotScript tool and GlotScript resource. Here we selected two popular corpora in the NLP community that are multilingual. We took 1000 sentences from each languages of each corpus and apply the GlotScript on each of those sentences, 1000 sentences, and then here we mark them with the GlotScript resource, the attested writing system of each language. And here we show, for example, 5 best or worst performing languages. For example, the language SOT in the MC4, which is the ISO code for Soto language. It is written in Latin, and also 1000 sentences was written in Latin. But on the other hand, the language Marathi is written in the Devanagari script, but many of the sentences in the MC4 was actually written in the Hani script, which is clearly an error. And also for the Oscar pipeline. We also check if filtering based on the links can improve some of these numbers. Yes, at some point it can, but not always. So not all of the sentences were written in the wrong script was actually short. So we do this recommendation that if you publish a corpus, it's better also you put the script inside of the corpus as a metadata, so that people know that this language is supposedly going to be written in those scripts. Since both MC4 and Oscar just uses the language ISO codes and not the script codes inside it, it happens to be these problems appear and not filtered beforehand. So GlotScript tool can be useful in that sense and do the script identification at sentence or document level. And also GlotScript resource can be used as another source to make sure that the published texts are written in the actual writing system that those languages use. Now let's jump to another use case of the GlotScript. This time we are going to analyze the pre-trained models. Actually, this analysis is more about the tokenizer of these language models, not the language models itself. And in this analysis, we decided to see the percentage of each script in the vocabulary of the model tokenizers. So we apply the GlotScript on the vocabulary of each model tokenizer, and you cannot do this with the, for example, language identification models, because language identification models, as you know, they cannot identify all of the scripts. And another important reason is that you cannot use them is because language identification models are not good at very short sentences or single words. So the best way to get an intuition on how much the tokenizer having is multilingual or have different scripts is to apply the script identification, which is completely accurate. And we have here 10 different models from the GPT-4 and decoder only models, and two even monolingual models such as BERT. We here listed 7 observations that we had. For example, we found out the BERT tokenizer does not support the Latin. It also supports Honey, Arabic, Cyrillic, and in additional scripts, in total 12 scripts. And on the other hand, we found out for some of the language models, the tokenizer, the representation for some of the scripts was scarce relative to the other models, such as Bloom, which seems the really Cyrillic representation is very less than the BS second category for language tokenizer vocabulary. And we found, for example, GPT-4 includes representation for 18 scripts. All of the models include the representation for 92 scripts, and the most multi-script supported tokenizer is GlotScript with 88, and the second one is MT5 with 66 scripts. In another experiment, we decided to apply these tokenizers into a parallel corpus to see how much they are fair in terms of the number of tokens they use to tokenize these corpus. We took 396 UDHR translations and applied these tokenizers into them. However, since some of the tokenizers that we have are not familiar with all of these scripts and they are not also at byte level, they produce unknown tokens. We didn't participate those pair of the tokenizer and translation, which produce more than 5% unknown tokens. We show them in the right figure. In the left figure, we have the actual result, the number of tokens used for each different tokenizer. And as you can see, for the byte level tokenizers, Bloom has a better representation overall. And in the non-byte level tokenizers, GlotScript has a better representation, but it may still produce unknown tokens for the languages it doesn't know. In the byte level tokenizers, we can see the GlotScript has the worst performance overall, and it generates more than 10 times than English Latin in all of the byte level tokenizers except the Bloom. And also we can see that BERT tokenizer can tokenize Cyrillic, Honey, and also Arabic without producing unknown tokens. So it shows that this model is not truly monolingual. Another use case of the GlotScript is helping language identification. We here introduce GlotLID, which is an open source language identification model which supports for more than 2000 languages. We use GlotScript in this project a lot. We use GlotScript to determine the script of the languages, try to clean them if they comprise multiple different scripts, and try to label them differently. But on the other hand, we also use GlotScript resource to find out which of these pair of the language scripts is really exists, and the people of that language use them. You can test it out in GitHub and also our demo in Hugging Face. As takeaways, we published a resource that covers the attested writing system for more than 7,000 languages. We also published a tool that helps to identify the script of any Unicode text. You can test both of them in our GitHub. Thank you for your attention.